The trapezoid is also a quadrilateral, meaning that it has 4 sides. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. The trapezoid has 2 and only 2 sides that are parallel. Those are called bases. So in this case, we have a parallel side and a parallel. In this case, these two are parallel, and in this one, our parallel sides are, again, the top and the bottom. In other words, we can make this trapezoid sit on either one of the bases. We call these base sub 1 and base sub 2. And that's interchangeable. You can make this one 1 and that 2. Here are our two bases, 1 and 2, 1 and 2. In a special case, this one is called an isosceles trapezoid. The isosceles trapezoid has one additional feature. The non-parallel sides, so these are the parallel sides, the non-parallel sides are congruent. So that would be the same measure as this one. In fact, really what we've done is we've taken an isosceles triangle and chopped off the point on this. If we took this triangle and cut off the top part of it, we would make an isosceles trapezoid. So that's just another example. So as such, the isosceles trapezoid has the two sides of it that are not parallel are congruent. In other words, they measure the same amount. So if this was 3, then that would be 3. The sides are congruent, the bases are parallel, and in the isosceles trapezoid, the base angles are congruent and the top ones are congruent as well. We call these two bases because if we flip this around, if we turn this around this way, then our base sub 2 and our base sub 1, this would be congruent, and these base angles would also be congruent. So I just other trapezoids only have the two parallel bases. That's all. In this particular one, we have a trapezoid with 2 right angles. In this one, we don't. All of the angle measures are different. When we're thinking about area and perimeter of the trapezoid, of course, our perimeter would just simply be adding all of the sides together on these. So it would be, you just add all the sides. So it would be A plus B plus C plus D, because there's 4 sides. So you'd start in one corner and you would just simply add, and add. In this case, start in any of the vertices and go add the length of this one, plus the length of this, plus the length of this base, plus the height here, this one. In the case of the isosceles trapezoid, since it has 2 sides that are the same, you might do perimeter is equal to 2A plus B plus C. So if we were to have this as our A, this is our A, we'd have 2 the same because they were measured the same. They were congruent. and then possibly a B and a C. But if you forget or you're worried about it, perimeter is simply add up all the sides, and if it's the same number, then you add it as you come to them. The area of a trapezoid is a little bit different because we've got some wasted space here. This part right here is wasted, and this is wasted here too. If this were our garden shape, if this were our garden shape, our rows would be uneven. We would not be able to get a carrot plant in that little bit, or this would be wasted. So this space right here would be a wasted space for planting. So we can't just go area equals base times height, like we could for the rectangle or the square that had the same amount of rows in the bottom, the middle, and the top part of the figure. So whenever we have any figure that has wasted space, there is a fraction in our area, 1/2. It's 1/2 because this is a two-dimensional figure. We have length and we have height. So area is equal to 1/2 base sub 1 plus base 2 times the height. So we're adding together our two bases, taking half of it, and then multiplying that number by whatever the height is. So the area formula for the trapezoid isn't quite as easy to remember as the square, rectangle, rhombus, and parallelogram was. But it does make sense when you realize you have two bases in each of the trapezoids. We're going to have to figure them both. So it's base 1, base 2. We add those two together. Take half of it and then multiply it by the height, which would be here. That would be the height. Here you'd have the height. Obviously, if you chose this as the height, it would be the same number because it's the same. These are parallel. The bases are parallel, so the height would be the same anywhere you would draw your line.